So I want to give you a, a quick walkthrough on what I consider for moving chemistry, particularly when it comes to synthesis. So when I'm using that reference, if we take a look at this particular synthesis pathway, where we're starting is we have chemistry at these two positions. Right? And if we look at our final answer, we have chemistry really there. So our chemistry has changed locations. We've moved from the red to the blue. So if anything, we need our chemistry to move kind of into the structure through the process of this. So when we're thinking about our reactions, we could go through and say, well, I have a pi bond, so I need to do an addition reaction. So we go, oh, I could use HBr and ROR. That is a perfectly valid reagent, and it will do an addition reaction. And if we look at that reagent sequence, that's what we would end up with as a product. Okay? If we now compare where our chemistries are, well, the chemistry is now here. If we look at this, what happened is we started with chemistry at 2 positions, and we now only have 1. Additionally, we had that chemistry move kind of outwards. If we look at where our goal is inwards. So our chemistry has moved the opposite direction of where we want it to go. Okay? So when we're talking about moving chemistry, or when I reference moving chemistry, that's what I'm referencing. How do I get that chemistry to shift from one position to another, and what is that sequence? The other part that I like to reference a lot is going through with the reactions to make these connections. So you'll note that I jumped right on reagents. Well, reagents is usually the wrong place to go. What I could go through and do is say that I need to do, not an elimination there, but an addition. And in this addition, I'm going to react that pi bond. I know the chemistry needs to move into the structure. So when I do that reaction, I'm going to lose chemistry out here, and I want chemistry to stay in here. Okay? I don't know what's there necessarily yet because, well, I don't know the reagent that I've used. But what I'm trying to do is find how I could move it. The next part I could go through and do is say, well, my chemistry still needs to move to a different carbon. Well, the only way I can get it to move to a different carbon is if I have a reaction that has multiple reactive carbon sites. Well, the pi bond had multiple reactive carbon sites, so doing an elimination is probably a good option. Now I've got chemistry where I want it. Okay, well, in this case, I could say, well, heck, can I just do an addition to jump this bridge? Okay. Will that work? Okay. What you're focusing again on is just what are those reactions that get you to these intermediate structures. And they aren't intermediates, these are formal products, right, in their own right, because reagents had to get us there. Once we have those, we can now start to think, well, what reagent would allow me to make that transition? If instead you're thinking, what reagent am I going to use to jump from point A to point B, you're going to get it wrong, okay? Or very likely get it wrong because you don't have command over what are those intermediate structures. Okay? So focus on writing down those intermediate structures. What are the reactions that you have available to you that make sense to move the chemistry you want to move? With that, that's all I really wanted to talk about. So we'll keep this a nice short video theoretically.